Let's take a look at decomposing of vector. For those of you going into physics, this is going to be relevant to some of the problems, the application problems that you look at in your physics course. Let's take a look at a little mini example to get an idea of what we're talking about. Let's pretend we have some type of incline and we have a box that is going to be sliding down this incline. Now this box is going to be exerting a force straight down, and I want to go ahead and break this force vector into two components. The first one, let's call it F1, is going to be the force of this box sliding down the incline in that direction. The second component, I'm going to call it F2, is going to be this force that is perpendicular or coming straight down from my box. In this case, F1 and F2 are perpendicular vectors. And let's talk about a couple formulas we're going to need here in this section. For vector 1, we're going to have the dot product of V and W. In our denominator, we're going to take the magnitude of W and we're going to square it. And then we're going to take that whole fraction and multiply it by vector W. For the second component, V2, we're going to take our original vector V and subtract out what we got here as our answer for V1. Let's go ahead and take a look at an example. Let's start with these two vectors. Vector V is going to be 1, 3, and vector W is going to be 1, 1. Let's go ahead and get the two components that we need, the dot product and the magnitude of W. When we calculate the dot product of V and W, we're going to multiply our x components, multiply the y components of each vector, and then add them together. So our dot product is going to be equal to 4. When we calculate the magnitude of W, keep in mind we are squaring each of the components, adding them together, and then taking the square root. When we do that, the magnitude of W is radical 2. Now let's go calculate vector V1. When we plug into our formula, our dot product was 4 on the bottom. The magnitude of W was radical 2, and we need to square that value. So this is going to give us a 4 on top. Radical 2 squared on the bottom is going to be a 2, and 4 divided by 2 is going to be positive 2. Then we're going to be able to multiply that number times vector W. So this is going to be the same thing as 2W, or 2 times the vector 1, 1. Keep in mind we can distribute here to get 2, 2 as our vector. Now let's go calculate the next piece, V2. Keep in mind, in order to calculate that, we're going to take our original vector V and subtract out V1, which is the piece we just got. When we subtract these two vectors, we're going to be subtracting the x components and then the y components. When we do that, we're going to get the vector negative 1, 1. Let's go ahead and plot these pieces. I'm going to go ahead and draw vectors V and W. I already have vector W on there. That was the vector 1, 1. Let's go ahead and put vector V on there as well. Here's our original vector W and our original vector V. Now let's go ahead and talk about what V1 and V2 look like in relation to this graph. V1 was the vector 2, 2. Notice when we draw that on our graph, I drew mine in blue. It is going in the same direction as W, or in this case, it is parallel to W. And if we put V2 on our graph, recall that V2 was the vector negative 1, 1. I'm going to draw this tip to tail, so it's going to start right here at that value 2, 2, and it goes left a unit, up a unit, so there's my v2 vector. Right. Notice that it is perpendicular to vector v1. So just some information here to recall. v1 in this case was parallel to w, and v2 was a vector that was perpendicular to w.